As we are continuing with the pre-connect line, we now set up for a Y, which will start from the side right-hand extra on this particular pump, run it through a 2.5-inch feeder line. We'll dial in about 400 feet of 2.5-inch feeder line. We have a single lay set up. We also have the option for a double lay. So let's leave it in a single lay for this setup. We will again run it through an elevation problem. From the elevation, which could also be in a standpipe, we'll run it to a gated Y, in which 2 1.5-inch lines have been taken off, each 1.5-inch line being 100 feet in length, and 2 nozzles on them, each being of 95 GPM capacity fog nozzle. While this second situation has been being set up, he has continually been flowing water out of his other pre-connect. If you look, you will see that his tank water has now gone down to half a tank. We'll now call for water on that number 5 discharge.
3812, please charge the number 5 discharge with the split Y.
That's all right.
As you see, there's been a tremendous drain on the system. If you look over at the instructor's panel, see we have a fail option. While holding this button down here, I've simulated a hose failure, so simulating that I do not have water. I'll call back to the truck requesting water.
3812 is 12 Alpha. We need water. Please give us water.
We'll then try to get water, and by gating the valve, by slowly gating that valve, you can determine that water is flowing through his discharge as the pressure gradually decreases. It will then determine that there must be a hose failure somewhere and relay that message back to me.
There must be a hose failure.
Then Roger, we'll shut down the line and we'll look over it.
Then shut down the line and look over the system, and we'll reset it up to see that all connections have been made. During this time, the water level has then gone down to a quarter tank, and then finally have the control to make his tank run empty. Now that he's ran out of water, you can see on the master gauge, his pressure has slowly decreased, and all pre-connects have failed him now. At this point, I can now, on the instructor's panel, switch his intake from tank to hydrant pressure. Now with this unit right here, I control his incoming hydrant pressure. For this low flow, I'll set his incoming pressure at about 60 pounds. He now has compound water. With the incoming pressure, he's now opened up his pump to tank and started bleeding some of that water off to fill up his tank if he needed. So we'll give him, let's say, a quarter tank of water. He has this set up. He now gets his compound gauge, keeps his cross-slate pressure the same, and adjusts his number 5 discharge. Now that everything else is happening, including the incoming pressures, we'll take a look to see how our nozzle pressure is doing with that first reconnect. As I can see here, we're up to about 140 psi, which is a little bit too much for that type of a fog nozzle. So we'll ask our pump operator to lower the pressure on that fog nozzle.
3812, please lower the pressure on that pre-connect.
I'll lower the pressure now.
Now we see over on the instructor's console that the pressure is very close to 100 psi. I'm going to take a look to see how he's doing on that standpipe. You see there? He's a little bit low. I can bring that up with his throttle. About 10 pounds. You can see we're now set on this unit, and he will correspondingly gate down his number 8 cross lay on another 10 pounds since he's brought up his master gauge, that 10 pounds. Also at this time, as you can see, we can start increasing his tank water. I believe he's gotten a full tank of water. You can open and close the nozzles on that fog nozzle to indicate an increase or decrease on the demand. As we open and close the nozzle here, you can see across his board increases and decreases in pressure that he's going to have to constantly adjust for. And I will leave the nozzle completely open. With the system set up as is now, the pump operator has a chance to set his relief valve for the pressures he's operating with. At this point, he will not adjust his relief valve. We're looking at the compact master gauge. As he sees that drop, he knows the relief valve is kicked in, and he brings it back up to the original pressure and sets it there. Now, as you can see, when I open and close the nozzles, it will no longer cause an effect on the master gauges with that relief valve set. Relief valve will absorb the shock of those opening and closing nozzles on the drain. Also throughout this time, you can simulate engine problems over here, such as a slow increase in the water temperature with a corresponding decrease in oil pressure. And it will be the instructor's, the student's job to notice these changes in temperature and pressure, as well as the idiot light that would light up in case of low water in the engine. Set everything back to normal.